Get ready to the countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by Didik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh. Alhamdulillah Rabbil Alamin. Bismillahirrahmanirrahim. So, good evening everyone. Hi teachers, parents and all wonderful students. So, welcome back to Pusat Tuisyen Academy YouTuber, a joint venture with Didik Malaysia and Kelab Guru Malaysia with the hashtag bermula percuma, selamanya percuma. So before we proceed, let's begin our session with the recitation of Kitab for the Muslim and for the non-Muslim, a moment of silence. Al-Fatiha. Okay, so before, how's everyone today? So my prayer that everyone is in a best of health and ready to proceed with today's class. So before we start, let me introduce myself first. My name is Nurmenti Muhammad Nur. You can call me Madam Nun and I am lecturer from College Matrikulasi Negeri Sembilan. I am your moderator for today's class. The most important person today is our passionate and fantastic presenter, Madam Rosmaya. She is a very experienced teacher from SMJK Yuhua, Kajang Selangor. So let us give a warm welcome to our presenter. For the record, we are now live on Madam Rosmaya channel. So as a sign of support to Madam Rosmaya for the hard work on preparing today's lesson, please subscribe her channel. As usual, the lesson will be approximately 1 hour. The certificate link and the credit claim link will be given at the end of this session. So remember that you can only use the email to claim the certificate. For the credit claim, you need to collect one letter, and for today's we have 5-digit code which will be announced separately during our class today. So be sure that you follow the class until the end to get the complete code for the credit claim. So I would also like to remind students, if you wish to post comment in the chat box, please use appropriate language and use appropriate profile picture. I am pretty sure all students here are excellent students who will uphold a positive classroom environment. Please give your full cooperation in making this class lively one. Okay, so stay focused, and if you have any question, please write on the chat box and we will try to provide you with the answers. Before I give to the Madam Rosmaya to present, I will announce the first 2-digit code, one letter and 2-digit code for the credit claim. So the first letter and 2-digit code is A20. A20 or A20. So without further ado, without further ado, please welcome Madam Rosmaya to start her presentation.
Okay, thank you, Madam Nun. Okay, I am Madam Rosmaya. Okay, so Assalamualaikum and good evening, everyone. Okay, I will guide you all through this live session, okay, on the topic oscillations and waves. So we are going to solve 20 questions, okay, given earlier down in the description part below, including some of the mock questions that I also prepared for you all. Okay, so before I begin, I would like to introduce the PRIU team. Okay, PRIU team in the Academy YouTuber. So the physics teams lead by me. Okay. Next, we have biology team. Okay, biology team lead by Cikgu Faiza. Okay, then chemistry team lead by Cikgu Shahnon. And mathematics teams lead by Teacher Im. And the perakaunan and ekonomi PRIU lead by Madam Fizi. Okay, so let's start. Before that, Academy YouTuber also has apps. Okay, you can download from the Google Play Store, and there are lots of video there, including our live session here in the apps. including the physics video there. Okay, so let's start our discussion. So in solving questions on oscillations and waves. Okay, question 1. Okay, we read the first question together. Okay, the diagram below shows the profile of a progressive wave moving through point P at the instant t equals to 0. Okay, this is a t initial, okay, starting from t equals to 0. Okay, this is the graph, displacement against distance. So if t is the period of vibrations of the wave, so which of the following graphs shows the correct profile of the wave at the instant t equals to t per 4? Capital letter T shows a period. Period. So this is period. This is the wave profile after t equals to t per 4, period per 4. So if you answered this question already, you can write there in the chat box. And okay, so now from the graph here, okay, t equals to 0 is here. Okay, then for the complete for the period t, so the complete wave is here, this one, here to here. This is the complete wave if period. Okay, time taken is period. Okay, so the section is there's a section here drawn already. There are 4 sections, so that means t per 4 is somewhere here. Okay, t per 4 is this one, because you are guide already from the graph. Right? There are 4 sections from here to here. Okay, so that means this is the wave. So this is the initial. Then after t to t per 4, it will move to the right. Okay, to the right. And the phase difference and the shape is similar to the answer B. The question asks for shape only, not the equation. So just refer the answer. The shape is B. So the answer is B. Very simple question. So you can get if you got the correct answer, you can write there in the chat box. Okay, now we go to the next question. Question 2. This time, similar to first question, but you need to form a equation. Okay, equation. So look at the answer. Let's read the question first. So the figure below shows 2 sinusoidal curves, P and Q. So we have 2 graphs, P and Q. Okay, which one of the following pairs of equations represents the curve? Okay, if you look at the answer here, it starts with P. So that means P will be the initial. Then the wave profile move to next shape Q. So that means we observe the curve is in the what equation for the curve P. Okay, because from the answer here it state P first. So the shape you see is the shape of the cosine graph. So automatically you know that the shape is y equals to the equation of the graph is y equals to a cos theta. So you must know lah these 2 different curve for cos theta and sin theta graph. Y equals to sin theta is like this. Y equals to cos theta is like this. So this one is similar to the cos theta. So for the amplitude, this is amplitude A. So y equals to a cos theta. Okay, so C and D is wrong lah the answer. So leaving only A and B. Okay, for A and B, it's either cos or sine, right? Because imagine this is the initial P graph, so it moved to the right. For moving, you just need to determine the 2 consecutive points. 2 consecutive points. So you can choose these 2 or these 2 or even these 2. It's up to you lah. And the wave profile move to the right. You see the wave profile move to the right. So that means it's minus, and the answer given minus already both. Minus already. So the equation must from the origin wave P, the wave profile move to the right, right? So must also cos. So y equals to a cos bracket theta minus phase constant phi. Because it moved to the right. Okay, if the wave move to the left, then this one will become plus. But you are lucky here because A and B here give you both minus. So for the wave profile to move to the right is minus. Okay, now the answer is A. But how to know the 5 per 8 here? Just in case if the question come out in the essay. So how to know the 5 per 8 pi? For the phase constant is very easy. So the given already in the graph for the half wave, this one complete wave is this one. So for half wave is equals to the pi radian. Okay, given in the graph here, pi radian. You can read there, you see, pi radian. So the section also divided already. This is 8 section. So that's mean for the phase difference between them for the phi, okay, will be 5/8 pi radian. Okay, so that's mean pi here, phase constant is 5/8. So you calculate, and you are given already here 8 section. So that's mean here is 1, 2, 3, 4, 5. The phase between the two wave profile. So the phase constant is 5/8 pi. Okay, that's the answer. Okay, so we done question A. Okay, next we go to the next question. Okay, question 3. An object of mass 0.50 kilogram performs simple harmonic motion with maximum kinetic energy 2.0 times 10 to the power of negative 3 joule and amplitude 15.0 centimeter. So what is its frequency of oscillation? So you are given mass, kinetic energy. So this is the maximum kinetic energy, and then amplitude, x naught, and we are going to find frequency. Okay, so for the kinetic energy, so we need to use the kinetic energy formula of the simple harmonic motion, and also to relate it with the FF frequency. So we are going to use this formula. Okay, this formula. So for the potential energy is half m omega squared x squared, and for the kinetic energy half m omega squared bracket x naught squared minus x squared. So x is the displacement, any displacement. X naught is the amplitude, amplitude or maximum displacement. Okay, for the maximum kinetic energy, okay, the x here is 0. Okay, x here is 0. So you choose kinetic energy equation here. This is the speed. Okay, the speed when you substitute here half mv squared, so you get this equation. Okay, to derive the equation, I won't go through detail. So I just take directly the equation. Okay, so for the maximum kinetic energy, this x value must be 0. Okay, mentioned there, maximum kinetic energy. So this x is 0. So the equations become for Kmax half m omega squared x naught squared. Okay, now we use this equation and substitute all the values given. Okay, so kinetic energy 2 times 10 to the power of negative 3 joule, and then mass 0.50 kilogram already in SI unit, and x naught is 15 centimeter. So be careful, convert to SI unit. So 15 times 10 to the power of negative 2 meter. Okay, don't forget the square. Okay, there's a square there, formula. And the omega is 2 pi f. 2 pi f. So you can relate frequency with the kinetic energy. Okay, by substituting omega equals to 2 pi f. Okay, now you rearrange all the values here to get f. The answer is 0.095 Hz. Very simple. Okay, you just need to memorize the equations here. Okay, if you realize here, Kmax is equals to the total of energy. You see? Because at Kmax, you will be 0. From the graph here, you can see. Okay, at Kmax, okay, at the amplitude displacement here, okay, they are equal using the formula equal in value actually, Kmax, because U0, because total of energy is K plus U. So U0, Kmax is this one. So that's why the E total is, the formula for E total is equals to the Kmax. Okay, so now we go to the next question. Okay, question 4 from topic intensity. Okay, sound radiates in a hemisphere from a rock band. Okay, if the sound level is 100 decibel at 10 meter, then find the sound level at 4 meter. Okay, so be careful with the intensity given here. This is intensity level. Sound level here 100 decibel is the intensity level. Okay, and distance given 10 meter and 4 meter. So you need to use two equations here. Intensity level, the symbol used is I level, and then the distance from the source, sound of source of the sound R1, and this is another one. And we are going to find the new intensity level. Okay, symbol SI prime. Okay, remember the formula for intensity. Okay, there are two kind of intensity. One is intensity level, one is intensity power per area. This is watt per meter squared, the unit used. So power is watt, A is meter squared. So for the point source, the area is 4 pi r squared because it's formed at certain distance from the point source. Okay, the shape of the area is a spherical shape. So that's why the area is 4 pi r squared. Another one, if the source is a linear, okay, the sound source is the linear. So the at certain distance from that linear source is a cylindrical shape. Okay, cylindrical shape. So the area covered here will be 2 pi RL. 2 pi RL. Okay, 2 pi RL. So the surface of the cylindrical here. Okay, 2 pi RL. So be careful with this two what you call this point source. Okay, then the intensity level is use this formula. I intensity level equals to 10 log base 10 bracket I1 per I0. So intensity level is used to compare the two between the two waves, intensity between the two waves by reference from the threshold of hearing, which is the intensity is equals to 1 times 10 to the power of negative 12 watt per meter squared. So when you substitute into the equation here, the intensity level becomes 0 decibel. So this sound level 100 decibel from 10 at 10 meter displacement will be 100 times intensity of the original intensity of the sound. So be careful. The difference between intensity and intensity level. Okay, so now we are going to use the two equations. These two equations is a point source. So from these two equations. Okay, so we form equation for this first. So use the 10 log 10 I1 per I0. Okay, so you substitute the 100 decibel 10 log base 10 I per I0. And for the second situation at 4 meter, we are going to find the intensity level here. Okay, I prime 10 log 10 I prime per I0. So we can be fine using this equation. So we solve this first. Okay, so cross multiply here, so you get this, and the equations convert to index form. So 10 to the power of 10 equals to bracket I per I0. So we do the same for the second equation. Okay, bring to the right side here becomes 0.1 intensity level, and convert to index form. So you get this, use log rule. Okay, then you form the ratio. Okay, ratio. Just to get the relation between this I to I equals to power per area here. So this I per I prime, okay, at two position, 10 meter and 4 meter. Okay, so now I it's not necessary to find. Or also you can use another method, substitute directly, and then or we can say a substitution method lah. It doesn't matter which method you use. Okay, now we have 10 to the power of 10 minus 0.1 intensity level divided equals to I per I prime. Okay, I per I prime. So this I, you form another equation from here. Okay, then you can substitute into here. Okay, for the I equals to power per area, one is from 10 meter position, another one is 4 meter position from the origin. So you form two equation. Okay, and it is hemisphere. So for hemisphere is half of the area. Okay, this is spherical shape, spherical surface. This is hemisphere. So it's divided by 2 or half of the 4 pi r squared. Okay, now form two equation, and then get the ratio for to substitute into here, I per I prime. Okay, so you just need 10 over 4. No, this one is 4 over 10. Okay, so we don't need P and 4 pi, cancel out. So that means I per I prime is 4 squared per 10 squared. Okay, so you substitute into here. Simplify, substitute into here. And you solve for I level. Okay, so very simple actually. Just use the simultaneous equation. And the answer is, okay, 108 decibel. B, the answer is B. Okay, so you can use substitution method or coefficient of by equating the coefficient of matter equation by equating the coefficient, or you can also use ratio method, like we did just now. Okay, so the answer is 108 decibel. Okay, so next we go to next question. Okay, question 5. Okay, a progressive wave of frequency 500 Hz is traveling with velocity 360 meter per second. How far apart are 2.60 degrees out of phase? Okay, so we are given frequency, velocity, and 60 degrees out of phase. How far apart means what is the distance between them? Because the answer here all in meter. Okay, so the phase is given 60 degrees. Okay, so how to imagine the phase? Okay, example, the analogy, you use this simple pendulum. So all these three simple pendulum, they are swing or oscillate in different phases, in different phase. So if they are in phase, so they will line up like this. You can see at certain time they will line up in one collinear line. Collinear, they are collinear. Okay, so in terms of wave, so that's mean the crest follow for the first wave equals to the crest at the same time to the other crest. Or if here throw, this is throw. Okay, these two crest. So this means the two wave here is in phase. If 100 degrees out of phase, so that's mean the crest and the throw at this position. Or another word, if you point the two consecutive points here, these two consecutive points, okay, so the distance between two is equals to the half lambda. Okay, that's why it says 180 degrees out of phase. So half lambda is equivalent to the pi radian. Okay, because one complete wave is 2 pi, so half of it will be pi. Half lambda is pi radian, so that's why it's 100 degrees out of phase. So if the motion, you can see, okay, the motion is one going up, one going down like this. Okay, this is the equilibrium state. Okay, so it move one up, one down at the equilibrium, starting from equilibrium up, down. So the motion is like this. Okay, so that is 180 degrees out of phase. But if it is 90 degrees out of phase, okay, so at the equilibrium position, one go up, okay, the other remain at the equilibrium first. So one go up, and then when this one coming down, then at the equilibrium start to move. Okay, so that is 90 degrees out of phase. So okay, so the phase is pi per 2 in terms of radian, but in the terms of lambda is 1 per 4 lambda. Okay, you see here 1 per 4 lambda. So we use lambda. The answer here is meter, right? So you use lambda. So you need to find lambda. So because given in 60 degrees, so you use 2 pi radian equivalent to 360 degrees. 360 degrees is lambda. For 60 degrees, so we are going to find the x. So we use V equals to F lambda to find the lambda. So you get 0.72 meter, and you use ratio to find x. So the answer x is 0.12. Okay, very simple. So that is how we get the how far apart from the two phase of the wave. Okay, so now we go to the next question. Okay, this is the mock question. Okay, not given in the what? But you can try it. If you are there, okay, you can write there in the chat box. Okay, maximum disruptive interference between the two waves occurs when the wave are out of phase by. Okay, so when these two waves they are superposed or interfere together, so they will become disruptive interference. They cancel each other. So that's mean this is pi radian. Okay, this one this one. So out of phase. So pi radian. The phase between them is pi radian. Okay, so now we go to the next question. Next question. Question 6. Okay, so none looks like no answer given there. Okay, so we go to the next. Never
Not
mind.
yet. They are very focused listening to your presentation.
Or am I explaining too fast? You can just write there in the chat box. I explaining too fast. Okay, so question 6. We go to question 6. We read the question. A stretch wire between two fixed points is allowed to vibrate in such a way that its center point is stationary. Yeah. So which of the following modes of vibration is possible? So which one? So this is a stretch wire. So imagine the two fixed point. This is a two fixed point. So they will form a standing wave. Okay. Form a standing wave. So two fixed point here. So the possible of waveform is this one. Okay, so you can imagine if slow motion, you can see the vibration is like this. But if it is because standing wave, if the speed is very high, so you will see the loop. You will see what we observe is the loop form. But slow motion is like this lah. So that's why we draw it up like this. The loop. Okay, this is at the first or at fundamental frequency, or we call this first harmonic. This is 2 loops means second harmonic, 3 loops form third harmonic, and so on. So the question asks for the center point stationary. Okay, so at the center point of the between these two fixed point, the two fixed points. So this is the center. So the stationary is here. These 3 point. Okay, these 3, 1, 2, 3. Okay, these 3 point. So the harmonic form is second harmonic, fourth harmonic, and sixth harmonic. So this is even harmonic. 2, 4, 6. So that means even harmonic. So the answer is D. Okay, so did you all get D or not? Okay, if you got, so you just write there, yes. So just to show that you are with us here. Okay, so that's the answer D. Now we go to the next question. Okay, this is the mock question, okay, for you all to do. Very simple actually. But this time, just now string, right? This time is a pipe. Pipe open at both ends, okay? Open at both ends, has fundamental frequency 150 Hz. So what is the shape of the graph, to your imagination? So what is the shape of the the standing wave? Okay, the speed of sound in air is given 300 meter per second. So how long is the pipe? Okay, frequency given, speed is given, and we are going to find the length of the pipe. Okay, so for the pipe open as both end, okay, so we find the lambda first, because we are going to relate the lambda, okay, the wavelength to the length of the pipe. Okay, so the lambda is V per F, so substitute the speed and the frequency, so you get lambda is 2 meter. So this is equivalent to the okay, we try and check how this wavelength relate with the shape of the wave. So the length is half lambda. Okay, the length for the pipe both opens end is equivalent to the half lambda. Okay, imagine like this. So this is open ends where here is antinode, antinode, and node. Okay, antinode, node, and node. So that means this is open at fundamental frequency. So we can forget about the other shape because the question asks for fundamental frequency. So the shape of the wave is equal to the length of the pipe is equals to the half lambda. Okay, half lambda. So you substitute this 2 meter into here and you get length of the pipes, which is 1 meter. So the answer is C, 1 meter. Okay, you also need to memorize for the pipe for one close end and one open. Okay, one close, one end. So one close, one end. Okay, one close, one end. That's mean here is node, here is antinode for fundamental frequency. Okay, remember for the rest of the shape of the frequency, here node, node 2 nodes, one antinode, and so on. Remember that one end always antinode, the other end always node for the closed pipe at one end. Okay, so another one is the actually, okay, the pipe consists of the compression and the refraction of the air molecules inside. But because it's hard to see the antinode and the node, so that's why the equivalent wave is used as a string, string wave. You see, string wave. But actually they are the same. Only that we cannot distinguish the note and the antinote part. So that's why when we draw here, we use the string shape of wave. Okay. So this is the shape of the wave. Standing wave by the string fixed at 2n, and this is the shape of the wave string when they are free at both end. So the top one is the fundamental frequency followed by the next frequency. Okay, so very
Okay,
good.
Madam Rosmaya.
Okay.
We want to take a break for a while for the
Okay.
advertisement. Okay.
We can continue.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata ganjaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, everyone, I will announce the second digit code for the credit claim. Okay, please listen carefully. So the second digit code is 2. Okay, number 2. The second, actually our third digit code is number 2. Alright, so Madam Rosmaya, you may proceed with your presentation. Thank you.
Okay, thank you, Madam Nun. Okay, we continue with the next question, question 7. So in the standing wave experiment, the string has a mass of 52.8 gram and length of 1.30 meter. So the string is connected to a mechanical wave generator that produces standing waves with frequency of F. So the other end of the string is connected to a mass of weight of 200 gram. So calculate the velocity of the standing waves in the string. Okay, so you are given mass of the string, length of the string. Another mass is mass of this weight. So be careful with these two mass. And then calculate the velocity. So we are going to find the velocity of the standing waves formed in the string. Okay, so the formula, okay, memorize this formula. So V equals to T, tension in the string divided by mu. This mu is mass of the mass per unit length of the string. Mass per unit length of the string. So we can calculate mass per unit strength given 52 gram, convert to kilogram. And the length is 1.3 meter. So the answer is 0.0406 kilogram, and the tension is given is equals to the weight here, because it make the string tension comes from the weight here. So T equals to mg. So mg is mass of the weight 200 gram convert to kilogram, and the g is 9.81. So you get this value and substitute into here, you get 6.95 meter per second. Okay, very simple. Just need to memorize this formula. Remember, in the STPM exam, this formula is not given. So by practicing, it helps you a lot in memorizing all the formula. Okay, next we go to the question 8. Okay. Anyone with the answer can write there in the chat box. Okay, I saw there in the comments only Chia Yao answer the question. Violet say yes. Okay, very good. I know you are here with us. Okay, so this is the mock question. Okay, the speed of a transverse wave on the stretched string can be changed by adjusting the tension of the string. So a stationary wave pattern is set up on a stretched string using an oscillator set at a frequency 650 Hz. Okay, so how must the wave be changed to maintain the same stationary wave pattern if the applied frequency is increased to 750 Hz? Okay, so speed depends on tension here. Okay, can be changed means speed here depends on tension. Okay, so the initial frequency this 650 Hz, and we want to the pattern is the same. Okay, maintain the pattern with the frequency 750 Hz. So that means the final we increase the frequency from 650 to 750 Hz. So we increase the frequency, but one condition, we need to maintain the pattern. Okay, so what does this mean if we need to maintain the pattern? So that means the same wavelength, the same wavelength. Okay, so from the V equals to square root of T per mu, okay, the VT, okay, V is when we change, T also change, right? But for the wavelength, we need to use another equation, V equals to F lambda, okay? So this lambda must be constant for the same pattern. So if lambda are constant, so the changes is between V and F. Okay, so when the F increases, what happens? V also increases. So therefore, the answer is C. Okay, the answer is C. The question doesn't ask for T. So if the V increases, T also increases with mu maintained or constant. But the question doesn't ask for T here, only V. So that means by this equation, we know already the answer. The answer is C. Okay or not? Okay, from the chat box there. Okay, Chia Yao. Okay, ask my. Okay, I'm fine, Chia Yao. Okay, next we go to the next question. Okay, question 8. Okay, question 8. Doppler effect. The question is on the Doppler effect. Okay, we read the question together. A police car with its siren of frequency 1000 Hz on 1000 Hz on travels at a speed of 25 meter per second. So a car traveling at 20 meter per second moves toward the police car. So if the speed of sound in air is 340 meter per second, so what is the velocity of the car relative to the police car? And what is the frequency of the siren heard by the car driver? Okay, so you need to find the question. There are two questions here, relative velocity and frequency detected. So that's mean the apparent frequency, frequency detected. So this original frequency, this is the speed of the car or the source, named as Vs. The police car has siren on it, so we name as V source. And the car traveling towards the police car is V naught, V observer. Actually, VO is V observer. Okay, and the speed of the sound wave, 340 meter per second. So can you remember the formula for the Doppler effect? Okay, the apparent frequency in Doppler effect, apparent frequency is given by V plus minus V observer divided by V plus minus V source, okay, times the original frequency. Okay, so we just need to determine plus minus here for the observer and the source. Depends on how it move, move towards or move away. So we use this to help you to memorize the sign for minus or plus. So if the source move towards the observer, so that's mean minus Vs, or if the observer move away from the source, also minus VO. Okay, so another opposite direction, if the source move away from O, is plus Vs, or if the observer move towards the source, so it's plus VO. Okay, so now from these two simplified how to memorize the plus minus. So you make a diagram for this one to see which one. So the police car move here, travels on the speed and move and the traveling and the car move towards the car. The car move towards the police car. So this is the police car move towards the observer. Diagram might help you to determine which one coming towards which observer or source or observer. So diagram help you a lot. So the police car move towards the observer, and the observer, the car move towards the police car. Okay, so this is Vs, this is VO. Okay, now refer to this one. S move towards O, so this will be minus lah. Okay, the source move towards the observer, so minus Vs. And for this one, observer, okay, move towards S. So look at the arrow here. Observer move towards the S, so that's mean plus VO. Okay, V observer. Okay, so now you can substitute all the value after you have determined the sign plus minus here, and substitute all the values here for the Vs and VO. And the answer is 1143 Hz. Okay, so we are lucky here because the answer given already D is for no need to find relative velocity. But it's okay, we can still continue finding the relative velocity for your, who knows, maybe the question come out in the essay question. So relative velocity car to the police car, this means if you memorize the formula for the relative velocity, so it's V car minus VP. So it's different from the change in velocity. Change in velocity, final velocity minus initial velocity. But relative velocity car to the police car is V car minus VP. Okay, that's the difference between formula, relative velocity and change in velocity. Okay, so now you substitute the V car. V car is 20, okay, here 20, and VP is 25. They are opposite with each other. So that's mean 20 minus negative 25. So in this case, I put to moving to the right as positive and moving to the left. Moving to the left as positive, moving to the right as negative. It doesn't matter because the question here doesn't mention the sign whether the question doesn't say and whether it moved to the left or right. So it's okay to get the magnitude only. But because they move opposite with each other, so one sign will be negative, the other sign will be positive. So you get the answer is 45 meter per second. Okay, so the answer is correct, D. 1143 just now we calculate, we got already the answer, but to find the relative velocity is using this formula. Okay, now we go to the next question. Okay, so this is the mock question, but actually no need to calculate, no need to use the formula just now, apparent frequency for Doppler effect. So you just need to understand what happened here so that you can get the answer here. Okay, a car siren has a frequency of 400 Hz. So the car is moving away from a junction at 20 meter per second. So there's a woman there standing at the junction. So what is the frequency heard by the woman? Okay, wah, Cahaya answered already. D. Okay, so how you know that D? Okay, so remember that the car is moving away. Okay, the car has siren. So the source moving away. So for the source moving away, so that's mean, imagine this is a police car. When the car moving away, heard by the woman here, so what happened? The wavelength is larger as the car move away. So that's mean the frequency will be lower from the relationship between V equals to F lambda. From the relationship between V equals to F lambda. So if the lambda decreasing, F increasing. Okay. Sorry, the source have frequency maintained. So when the speed move, when the car siren here move away, so what happened? The source move together. The source of sound move together. So leaving that the wavelength on the right side, leaving the woman become larger. The wavelength become larger. So therefore, so if the like this animation I show you. Okay, so the car move away. So on the right side, the wavelength become larger. When the wavelength become larger, so that means the frequency less. Okay, 400. So the answer is 390 Hz. So without calculation, you can answer already. Okay, larger wavelength, larger wavelength, lower frequency. Okay, larger wavelength, lower frequency. So it's supposed to be less than 400. Okay, I hope you all understand. Okay, larger wavelength here, larger wavelength. So that means the frequency heard will be less. Okay, so now we go to the next question. Question 9. Okay, so anyone that answered this question already can write there in the chat box. Still nobody write there, Madam Nun? Okay, so never mind, we continue. Maybe one week not enough, not enough time for the all to do. Am I right? Okay, we read the question 9 first to answer this question. A police car siren vibrates with displacement Y where y is given as a sine 250 pi t. Okay. Okay, this sound causes the diaphragm of an eardrum of an observer 600 meter away to vibrate. So if the speed of sound is 340 meter per second, calculate the frequency of the sound. Then the number of the wavelength of this sound between siren and the eardrum. And then the phase difference between the vibrations of the siren and the sound. And lastly, the maximum energy of the eardrum if its mass is 1 times 10 to the power of negative 5 kilogram, and the amplitude of its vibration is 1.01 times 10 to the power of negative 8 meter. So we do one by one. A, the frequency of the sound. Okay, for the frequency of the sound, we can get from the equation here. Okay, from the equation, the general equation is y equals to a sine omega t. A is amplitude. So omega is the equivalent to the 250 pi. Okay, omega is the angular frequency. So omega equals to 250 pi, which is equals to 2 pi f. So you equate them, you can get the frequency. So the answer is 125 Hz. Okay, done for question A. Very simple actually. You can easily get the equation by comparing with the general equation of the wave, progressive wave equation. Okay, now we go to B. The number of wavelengths of this sound between the siren and the eardrum. Okay, the number of wavelength. So for question B, imagine this is the eardrum, the police car siren, the observer. This is the observer. So there is a number of wavelength to reach the eardrum of the observer here, from the source of current, source of siren. Sorry, current. Source of siren. Okay, so now from the V equals to F lambda, okay, the V is given here 340 meter per second. So you can calculate this wavelength. Okay, so substitute into the equation here, frequency just now 125 Hz. So we can calculate the wavelength. So the wavelength is 2.72 meter. Okay, but the distance between the observer and the siren is 600 meter. Okay, so how many wavelength are there between the two of them? Okay, so this 600 divided by 2.72, we can get the number of wavelengths, which is 220.6 number of wavelength. No unit because it's the number of wavelength, right? So that's the answer, 220.6. So we put it here. Okay, then next. Hopefully you all understand. If you understand, you can write there in the chat box. Okay, question C. Continue with question C. The phase difference. We are going to calculate the phase difference between the vibrations of the siren and the sound. Okay, from the siren and the sound. The siren and the sound heard by the observer. Okay, so this is the siren. Okay, the wave profile of the sound wave. Okay, move towards the observer here. Okay, heard by the observer. Okay, now for before it reach the phase the wave profile shown is this one, and after it move and heard by the observer, okay, so it's the phase between them is 0.6. We can get from here 220. Now this is number of we can make it equivalent to the path difference, actually number of wave lah. Path difference can be in meters, but we can use the number of wavelength instead. So number of wavelength we calculate already 220.6 to reach the man here, to reach the observer here, 220.6. So the complete wavelength, okay, before it reach is 220. So that means the difference between the two wave profile is actually 0.6. Okay, 0.6. So from here we can calculate the phase difference. So the phase difference is in pi radian. So 0.6 times 2 pi, because we are going to convert the number of wavelength here to radian. So that's why we times 2 pi. Okay, so 2 pi is equivalent to one wavelength. If 0.6 wavelength, okay, times 2 pi, you get 1.2 pi radian. So this is the answer. 1.2 pi radian. Okay, so done for question C. Or you can times 3.142 or times the pi, you get this answer. So you can leave your answer, it's up to you, in the pi or in the 3.77 direct. Okay, we put it here, the answer. Okay, then question D, the maximum energy. Okay, maximum energy, we use the formula in the previous slide, shown you already. Okay, so the eardrum actually undergoes simple harmonic motion. Okay, simple harmonic motion. So therefore, we can use the formula half m omega squared x naught squared. Okay, for the maximum energy. And also in the previous slide, this is also the K max, kinetic and maximum kinetic energy, and also is total energy. So half m omega squared x naught squared. So we can use this equation. Now substitute everything. Omega is 2 pi f. Okay, substitute all that we have calculated above into here and given in the D question. And the energy is 3.1 times 10 to the power of negative 16 joule. Okay, so done for question 9. Okay. And the last question, the last question. Okay, still got time, right? Okay, we have 10 more minutes. So I think we managed to finish all the question given to you all. Okay, we read the question together. The diagram below shows the plan of a horizontal disc of radius r rotating about its center O with a constant angular speed omega. Okay. A vertical rod fixed on the rim of the disc is illuminated by light, okay, and the shadow of the rod can be observed on a screen nearby. This is the screen. This is the disc and this is the light, okay. So if the shadow is at P at the instant t equals to 0, show that the motion of the shadow of the rod is a simple harmonic motion. Okay, B we can do later. We do question A first. So can you imagine this or not? This is the static diagram drawn for you. But to help you to imagine, I give you this animation. This is the disc. So there's a rod here. So at its move rotating in a circular motion, okay, it's rotating in a circular motion. So the shadow form on the screen here. There's a light here, right? There's a shadow. And can you see that the shadow move to the left and to the right? So the equilibrium position is at the center here. Okay, x equals to 0, x equals to A, amplitude is the maximum displacement, okay, which is equals to the radius of the circular disc here, So that's how to imagine. So even though the diagram given static like this, you must be able to imagine. It helps you a lot to solve the equation, to solve the question here. Okay, from top view, okay, you can see. So the motion of the rod, the shadow of the rod here, move up and down in simple harmonic motion. So we are going to show this is simple harmonic motion. So how are we going to show that the motion of the shadow is the simple harmonic motion? So you must know what is the definition for simple harmonic motion. Okay, so we start with the I make the diagram larger from top view. This is from top view. The diagram here shows top view. Okay, so to show that this is simple harmonic motion, you must know the definition of the simple harmonic motion. So the definition for simple harmonic motion is acceleration equals to the negative omega squared x, where acceleration of the object here is always towards the center, the equilibrium position. X always towards the equilibrium position. So that's why it's negative. And then omega is the angular velocity, the angular velocity of the object. Okay, we are going to prove this. So to find the acceleration, okay, so this is 0 to A is the displacement. Okay, maximum displacement is A, but the range between this we can relate with the radius of the circle. You form this triangle. Okay, so this is x, this x value, displacement. X is displacement. So you need to find the displacement. So the displacement, we can relate with the radius given in the question there. The radius is constant given there. So this is r. And the angle here, let's say theta. Theta we can relate with omega. Okay, theta. So theta is omega t. Okay, theta is angular displacement. Okay, omega is angular velocity. Okay, so theta and r, so we can use trigonometric ratio to find x. This is x. So using trigonometric ratio, so catua, so we use sine. Sine theta is opposite x per r. So you rearrange, you get x equals to r sine theta. So this is x, x r sine theta. And then theta is not given, right? But omega is given. Angular velocity is given. Angular speed is given omega. So we can substitute theta here as omega t. Okay? R sine omega t. Because omega is given, R is given. So we get the form relationship between x and t. T as time going by, okay, as the time pass by, so the object move up and down, up and down, or in simple harmonic motion. So we not yet prove yet it as the simple harmonic motion yet. Okay, so to prove the angular frequency here, so V is to prove to relate with A, okay, so we find V dx by dt, and then next is A dv by dt. Okay, can get the idea? Okay, so the V is dx by dt, so A is dv by dt. So from here, we derive this equation, x equals to r sine omega t. So we derive, we get r omega cos omega t. Okay, you've learned this in maths t, right? Maths t, how to derive. So sine become cos, and then the omega t here bring to the front. So r omega cos omega t. Okay, and then we derive again to get acceleration. So derive dv by dt, so you get negative r omega squared sine omega t. So the cos here, when you derive, you get negative sine, and again omega here bring to the front, we get negative r omega squared sine omega t. And then to relate with the r sine omega t here, factor out negative omega squared bracket r sine omega t. This is equals to the x. Okay, r sine omega t is the x. So you substitute into here, and then you see, can see or not? This is in the form of simple harmonic motion definition. Earlier, we give definition. We know that definition for simple harmonic motion, A is equals to negative omega squared x. So we proved that already. Okay, it is proven. And you write the statement, okay, omega squared is a constant, okay, then A is directed towards a fixed point, and A is directly proportional to x. So it is proven that the motion is a simple harmonic motion. Okay, done. Okay, hopefully you all understand. Then we go to question B. Okay, question B. Okay, if radius r of the disc is 2 centimeter and it rotates at 0.5 revolutions per second, so what is the maximum speed of the shadow of the vertical rod, and at which point in the motion does it occur? Okay, so for the speed, we use this equation given already in the earlier slide. V is equals to plus minus omega square root of x naught squared minus x squared. Okay, so x naught is 2 centimeter. Which is equals to the radius, okay, of the disc, and rotates of 0.5 revolution per second. So what does this mean? This is frequency, okay, because in 1 second it made 0.5 revolutions. So that means this is frequency. Remember, frequency is a number of number of revolution in 1 second. Okay, so maximum speed, it is understood for at maximum speed, x here must be 0. Okay, x here must be 0, maximum speed. So the equations become V equals to omega x naught. Okay, we just take the magnitude only because up and down the displacement is still x naught. Maximum displacement. For maximum velocity is omega x naught. Okay, omega is 2 pi f. You can substitute this f into here. Okay, now you calculate, you get V equals to 6.28 centimeter per second. Okay, And at which, remember there are two questions here. Don't forget, many students make careless mistake here. After found the answer, they forgot that actually there are two questions here. Okay, and which next question is, at which point in the motion does it occur? So maximum speed is at the point P here, okay, at the equilibrium position. So you just mentioned at point P. Okay, this is where the maximum speed is. Okay, at X node, amplitude, the speed will be 0 before it turning back. Okay, so that's all for today. Okay, I pass to Madam Nun.
Okay, thank you, Madam Rosmaya. So with God's grace, we have reached the end of today's lesson. Congratulations to those who are able to follow lesson from the beginning till the end. Before we end our session for today, I will announce the last 2-digit code. So for the credit claim, so the last digit code is 84. Okay, 84. Clear, right? Okay, so make sure that you complete all your digit code. There are 1 letter and 5-digit code. Okay, so all of you, please stop posting your comment for a while and click the subscribe button and activate the icon bell so that you will not miss the next class lesson. Then, if you find that the lesson was beneficial, click like and share to your friends on your social media. Spread and share the goodness. Once complete, type done on the chat box before the certificate link is given as a token of thank you for your dedication in joining the free online class today. So I will put the link for the certificate and credit claim in the chat box now. Okay, wait now. You can fill in after this. So this is the link for the certificate, and the second link is for the credit claim. Okay. Wait, so I hope that you will have no problem to fill in these two links. Okay. So, okay. Please take note that the link will end half an hour after this live. Make sure to use the EDD email or MOE email only to log in. Okay. Incorrect email use will not be entertained. So if you haven't got one, please apply the link to and to apply the EDD email is already given in the chat box right earlier class. So if you wish to get more information on the online classes, go to the academyyoutuber.com, and to those who haven't joined EDD Junior Telegram, please do so. So once again, I would like to thank all students for joining today's class. You are awesome. Feel free to share this free tuition class to your friends and teachers all over Malaysia. This is the collective effort from the teachers throughout the Malaysia for the students throughout the country. Thank you for being a YouTuber Academy supporter too. So I think that's all for now. See you in the next lesson. And please remember the hashtag bermula percuma, selamanya percuma. So, Assalamualaikum. Stay safe till we meet again next week at the same day and same time. Okay, bye everyone.
Bye-bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.